Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important CSIR Advanced Quantum Mechanics syllabus. Already I told you a core syllabus, almost so many videos I did, so many questions from each and every word in the quantum mechanics core syllabus of the CSIR. I detailedly explained all the things. Now I am coming into the advanced part. So in advanced part also one question I told, that is the WKB approximation question I told to you. That is the WKB approximation method is to solve the energy values of a Schrodinger wave equation. We need to use WKB approximation method. After the WKB approximation method, according to your advanced quantum mechanics of the CSIR syllabus, that is the scattering theory. The scattering theory, in the elementary theory of scattering is there. In the elementary theory of the scattering, that question I took, the first part you have to take it as a differential scattering cross section. The differential cross section for a scattering target is given by, they are giving the differential scattering cross section, they are giving d sigma of theta comma phi is divided by d ohm. D sigma of theta comma phi is divided by d ohm is equal to a square plus b square into cos square theta. This is the differential cross section for the scattering target. So if n is the flux of the incoming particle, what you have to write it is n is the number of flux of the incoming particle. Flux of the incoming particle is equal to n. You have to write it is the flux of the incoming particles is equal to n. What we need to calculate, the number of particles scattered per unit time. What is that? Therefore, the number of particles scattered per unit time, the number of particles scattered per unit time, the number of particles scattered per unit time is equal to sigma into n. So therefore, first we need to calculate the cross section. We need to calculate what we have to calculate, total scattering cross section we need to calculate. Are we able to calculate the total scattering cross section? Sigma of theta comma phi is equal to 2 phi into, we know the formula, 2 phi into integral 0 to 5 d sigma of theta comma phi is divided by d ohm into, we have to write it as a sin theta d theta, sin theta d theta. This is the formula for the total scattering cross section. The total scattering cross section formula this one, but you know that sigma of theta comma phi is equal to 2 phi into integral 0 to 5 d sigma by d ohm is equal to a square plus b square into, which one we have to write it is cos square theta, b square into cos square theta into sin theta d theta we have to write. So now you have to bring inside. So what will happen, you able to see 2 phi into our single integral become as a double integral 0 to 5 a square sin theta into d theta plus integral 0 to 5 b square cos square theta into sin theta into d theta, you have to write it. So therefore, a square you able to take outside. So what you are going to get it here, once you have to see sigma total scattering cross section, sigma theta comma phi is equal to 2 phi into integral a square you have to take outside, integral 0 to 5 sin theta d theta, plus b square you have to take it as outside, integral 0 to 5 cos square theta sin theta d theta you have to take. So therefore integral sin theta d theta is equal to minus cos theta. You have to apply the upper limit and lower limit. So 25 into a square into 2 you are going to get it. So how much you are going to get? So you are going to get this value is 2. So plus b square into, so let you have to take to solve this. So you able to consider as a let x is equal to cos theta you have to write it is. So dx is equal to minus sin theta d theta you able to write. Theta is equal to your limits are 0 to 5. So therefore x is equal to your limits plus 1 to minus 1 you have to write it is. So therefore you have to change that. So integral minus 1 to plus 1, integral minus 1 to plus 1 x square into dx you able to write it is. So therefore 25 is divided is a 25 into, we have to write it is 25 into 2a square plus b square into, this is the b square into, you have to write it is x cube is divided by 3 minus 1 to plus 1 you have to take. So therefore 25 is into 2a square plus, so first you have to apply the 1 by 3 minus into minus plus 1 by 3, 2b square is divided by 3 you are going to get it. So 2 in you have to take outside, you are going to get it as a 4 5 into a square plus b square by 3 you are going to get, which is equal to sigma of theta comma phi. But what we are going to get? We are going to get it as a number of particles scattered per unit time. The number of particles scattered per unit time is equal to sigma into n. How we are going to get is the number of particles per scattered per unit time. Therefore the number of particles scattered per unit time, the number of particles scattered per unit time, the number of particles scattered per unit time is equal to sigma into n. What is your sigma? Your sigma is 4 5 into n into a square plus b square is divided by 3 you are going to get. This is your answer. That answer is you have to check in the options. What are your options? Once you have to see 4 5 n a square plus b square by 3. The option D is correct. Option A is wrong. Option 1 by 6 is wrong. 1 by a square is wrong. 4 5 n a square plus 1 by 3 into b square. Like this we have to do in our competitive examination. For how many marks? For 5 marks they may get. So 5 marks question, it is in the advanced quantum mechanics from CSIR syllabus, right? So if you really likes, we started the CSIR and GATE physics online coaching we are starting. We have one app, that is Quantum Online Academy app. Go to the Play Store and download our app. After downloading our app, you able to see the courses. What are our courses? CSIR and GATE physics course, JL physics content and DL physics content will be appear like this. So not only this, individual papers also available. Till now these 4 papers we are finishing. The first one is mathematical methods of physics. The second one is classical mechanics. The third one is which one it is? Electromagnetic theory. The third one is electromagnetic theory. Now we are teaching the fourth one, that is the quantum mechanics we are teaching. This is the 4th paper of the quantum mechanics. Almost we are ending. Only 2 topics we left behind, that is the relativistic quantum theory and the semi-classical theory of radiation. So those 2 topics will finish, then entire the quantum mechanics also finish. We are under the advanced quantum mechanics right now. So that's why I am uploading that advanced quantum mechanics questions. So these 4 papers according to the CSIR syllabus, core and advanced part both we are teaching that recorded classes are available. These 4 papers are now recorded only. If you have to join right now, maybe the couple of days, after 10 days I have to start the thermodynamics and statistical mechanics. If you have to join in that time, you able to listen the live classes also. Please share and subscribe and like our YouTube channel. Like these videos, we will upload in our YouTube channel daily. Listen and enjoy our YouTube channel classes. Thank you so much.